वेलकम टू एनचिकॉन ऑनलाइन अकेडमी। इस लेक्चर में हम टेस्ट नंबर 3 की डिस्कशन करेंगे। The first MCQ says volume appears in denominator in equilibrium constant expression. If pressure is increased, then the reaction moves. So जब भी equilibrium constant की expression में volume denominator में आए, it means that the number of moles of products is greater and number of moles of reactants is smaller. सो जब भी प्रोडक्ट्स के मोल्स रिएक्टेंट से ज़्यादा हों तो प्रेशर इंक्रीज़ करने से रिएक्शन उधर जाएगा जिधर नंबर ऑफ मोल्स कम है। सो इफ़ वी इंक्रीज द प्रेशर द मोल्स ऑफ प्रोडक्ट्स आर मोर एंड रिएक्टेंट्स आर लेस, सो रिएक्शन मूव्स बैकवर्ड। सो बी इज़ द करेक्ट ऑप्शन। Dilute HCl is added to following equilibrium at constant temperature. So what happens with addition of dilute HCl? So HCl gives H plus and Cl minus ion. Now this H plus is a common ion also present in this acid, so it suppresses the ionization of this acid. So acid की ionization suppress होने की वजह से हमारे पास इस ion की concentration decrease करेगी। Choose the correct statement. Equilibrium is dynamic. It is correct. Equilibrium involving gases can be achieved in open vessels. This is wrong. We need closed vessel. At equilibrium, concentration of different substances are different at constant temperature. तो एक temperature पे concentrations are not different. So A is the correct option. For a reaction, value of Kp is proportional to square of term RT. So it means Kp is equal to Kc into RT raised to the power 2. Now this 2 shows that products minus reactants is equal to 2. So in this reaction products are 4 and reactants are 2. So 4 minus 2 is equal to 2. So this is the correct option. The relationship between K1 and K2 for the given reactions is. Now here N2 and O2 are given as products and here they are given as reactants. So it means that K1 and K2 are inverse of each other. Now here 2 moles of NO are given and here 1 mole of NO is given. So it means that K1 is square of K2 because whenever we will write NO, we will write square here and here we will write simply NO. So K1 is equal to 1 by K2 square. So C is the correct option. 2 moles of PCl5 are heated at 400 degrees centigrade. So PCl5 is heated and we get PCl3 and Cl2. At equilibrium, 40% of PCl5 decomposed to PCl3 and Cl2, its Kc will be. So 2 moles are taken in 2 liter. So 2 divided by 2, the concentration of PCl5 is 1. If at equilibrium 40% is decomposed, so 60% is left. So it means that 0.6 is left and rest 0.4 is converted into both PCl3 and Cl2. Now the Kc would be equal to products which are 0.4 square divided by reactants which is 0.6. So dividing these we get Kc is equal to 0.267. Given the reversible reaction N2 plus O2 forms 2NO, if initially 2 moles of each N2 and O2 are taken and the concentration of NO at equilibrium is found to be 2 moles, the value of Kc for the reaction is. So we have N2O2, they form 2NO. Initially we take 2 moles of each and 0 moles of this. Now at equilibrium we can write we have 2x moles of NO, 2 minus x moles of O2 and 2 minus x moles of N2. So now we know that 2x for 2NO is equal to 2. So it means that x is equal to 1. So we can write 2 minus 1, 2 minus 1. So 1 mole of each N2 and O2 are present at equilibrium and 2 moles of NO are present at equilibrium. Now Kc is equal to NO square, so it equals 2 square divided by 1 into 1, so it is equal to 1 square, so it equals 4. So B is the correct option. When N2 gas is added to equilibrium at constant pressure, the equilibrium shifts to direction in which there is. Now whenever an inert gas is added to an equilibrium, it can be added at 2 conditions. First at constant pressure and second at constant volume. Now adding N2 at constant volume does not affect the reaction, but adding it at constant pressure affects the reaction. Now if at constant pressure inert gas is added, so the system moves towards increased volume. So the system will move where there is increase in number of moles of gases. Two reactions are given, K1 and K2. If value of K1 is 4, the constant K2 equals. Now here we have A here and here we have A here. So it means that K1 and K2 are inverse of each other. Now K2 has 4 moles here and K1 has 2 moles here. It means that K1 square equals K2. So we take K1 square, then we will get K2. So now if the value of K1 is 4, the K2 equals. So K2 is equal to 1 divided by K1 square. So if value of K1 is 4, so 4 square is equal to 16. So the value of K2 is equal to 0.0625. So D is the correct option. Which two combinations generate a buffer? So let's take 1 mole of FeOH2. It would give us 2 moles of OH minus ion. And then we have 1 mole of HCl. It gives us 1 mole of H plus ions. So 1 mole OH reacts with 1 mole H here and give us water. Now if we see the balanced chemical equation for the reaction, so we have FeOH2 which is 1 mole, plus we have HCl in the balanced chemical equation which is again 1 mole, and it gives us FeCl2 plus 2H2O. Now according to balanced chemical equation, 1 FeOH2 requires 2 HCl. Now if we have 1 mole of HCl, it will react with 0.5 moles of FeOH2. So it means that we will have 0.5 moles of FeOH2 left, and along with that we will be having 0.5 moles of FeCl2 as a product. So as a result we get a weak base and it's salt with strong acid, so it is a buffer. Given a reversible reaction, if Kc for the reaction equals 15 and equilibrium concentration of A and B are 2 and 10, the equilibrium concentration of C would be. So we write Kc is equal to B into C square divided by A square. So Kc is equal to 15. Concentration of A at equilibrium is 2, so we take 2 square here. Concentration of B at equilibrium is 10, so C is unknown. So now 2 square is equal to 4, so 15 multiplied by 4 is equal to 60 divided by 10 is equal to C square. So C square is equal to 6 and C is equal to under root of 6, which is equal to 2.45. So B is the correct option. Given the equation, A plus 2B forms 2C for an elementary reaction. So for elementary reaction we can write rate is equal to rate constant into A raised to the power B raised to the power 2. If 2 moles of each A and B are reacted, the rate of reaction is 24. So rate is 24 when 2 moles of each of them are reacted. So 2 square is equal to 4 into 2, 8. So it means that rate constant is equal to 3. Now what is the rate of reaction when 4 moles of reactants are taken? Now K is equal to 3, and if 4 moles are taken, so we can calculate the rate. 4 square is equal to 16 into 4 is equal to 64, and 64 into 3 is equal to 192. So D is the correct option. Half-life of a radioactive decay reaction. So radioactive decay reactions are first order reaction. It is 10 seconds. If concentration of sample is 2, the rate constant equals. So for first order reaction, the equation for half-life is equal to 0.693 divided by K. So half-life is 10 seconds. Now we have 0.693 divided by K. So K is simply equal to 0.693 divided by 10. So we get 0.0693. So A is the correct option. If 4.6 gram of ethanol is reacted with 6 gram of acetic acid and at equilibrium 2 gram of acid is found, the value of Kc is. So now we have ethanol plus carboxylic acid. They give us 1 mole of ester plus 1 mole of water. So we have 4.6 gram of ethanol, which is equal to 0.1 mole, and we have 6 gram acetic acid, which is again equal to 0.1 mole. Now at equilibrium the concentration of carboxylic acid is converting 2 gram into concentration. So 2 gram divided by 60 is equal to 0.0333. So this is its concentration at equilibrium. So concentration of ethanol is also same. Now concentration of ester at equilibrium would be, so here we have the equation x, here we have 0.1 minus x, and here we have 0.1 minus x. So if 0.1 minus x is equal to 0.0333, so x is equal to 0.0666. So now Kc is equal to concentration of ester, which is equal to 0.0666 divided by concentration of ethanol and acetic acid. So we take 0.0333, 0.0333. Now the concentration of, if ester is 0.0666, so that of water is also the same. Now here we cancel them out. So Kc is equal to 4. So C is the correct option. When Qc is greater than Kc, which reaction proceeds at greater rate to achieve equilibrium? So if Qc is equal to Kc, so it means in order to achieve equilibrium, the reaction will reverse so that Qc becomes less and becomes equal to Kc. So reverse reaction occurs at greater rate. Given the reaction, PCl5 gets converted into PCl3 and Cl2. If the reaction occurs at minus 263 degrees centigrade, what should be the value of Kc to make relationship between Kp and Kc equal to Kp is equal to Kc square? So Kp is equal to Kc into RT delta N. Now here moles of products are 2, moles of reactants are 1, so this delta N is equal to 1. Now the temperature given here is equal to, so R is 0.0821, temperature is 10 Kelvin. So we write 10 Kelvin here raised to the power 1. So now this term equals 0.821 into Kc is equal to Kp. So now if we want to make Kp is equal to Kc square, so we should take this Kc and this should also be equal to Kc. So if Kc is equal to 0.821, so Kc square would be equal to Kp. So A is the correct option. If the ratio between Qc and Kc is 10, so ratio between Qc and Kc is 10 raised to the power 2. Qc is larger by 10 raised to the power 2. Now concentration of products at the time of measurement is 10 raised to the power 6 and that of reactants is unknown, and at equilibrium it is 10 divided by 1. So if Qc is greater than Kc by 10 raised to the power 2 times, so it means if it is 10, it is equal to 10 raised to the power 3. So concentration of reactants is equal to 10 raised to the power 3. So this is Qc. Now, what will be the concentration of products at equilibrium if reaction reverses to make Qc is equal to Kc? Now the number of moles are same on both sides. Qc is equal to 10 raised to power 6 divided by 10 raised to power 3, and if we have to make it equal to Kc, which means equal to 10, so we will decrease the reactants by 1 and increase the products decrease the products by 1 and increase the reactants by 1. So this is the concentration of products and reactants. So 10 raised to power 5 is the correct answer. For a decomposition reaction, increase in temperature. So decomposition reactions are usually endothermic, and for endothermic, increasing the temperature makes the reaction go forward. And when it goes forward, more product is achieved, and hence if product is greater, the value of Kc is also greater. So A is the correct answer. A salt Ab2 is dissolved in water and concentration of ions B is found to be 2 into 10 raised to the power minus 2. So B is twice that of A. So if B is 2 into 10 raised to the power minus 2, A would be 1 into 10 raised to the power minus 2. So now for salt AB2 type, we have Ksp is equal to 4x cube. So here x is equal to 1 into 10 raised to the power minus 2. So we can write 4 into 1 into 10 raised to the power minus 2 cube. So we get 1 into 10 raised to the power minus 6 into 4 cube. So 4 into 4 is equal to, we get 4 into 10 raised to the power minus 6. So C is the correct option. Consequence of buffering H plus ion by acid buffer is, so this is basically acid buffer which contains a weak acid and salt with a strong base. So whenever H plus ion is added, so this salt ion accepts this H plus and gets it converted into neutral acid. So if buffering is done by H plus, so it leads to increase in concentration of unionized acid. Rate equation can never be written directly from reaction equation 4. So rate equation can never be written for zero order reactions because zero order reactions are never single step reaction. So if they are never single step reaction, it means that we always need to know the slow step for zero order in order to write rate equation. So it cannot be directly written from the simple equation. Molecularity is not same as order for slow step. Generally for slow step, molecularity and order are same. But if the reaction is zero order or negative order or fractional order, molecularity and order cannot be same because molecularity cannot be zero or negative or fractional. So A is the correct option here. For exothermic reaction, activation energy of reverse reaction can be written as. So this is the graph of exothermic reaction. These are reactants and these are products. Now this is the activation energy. And the energy difference between products and reactants is called heat of reaction. So if we talk about reverse reaction, which means that products is getting converted into reactant, so energy of reverse reaction can be given as sum of activation energy and heat of reaction. So we get here energy of activation for forward reaction, this one, plus heat of reaction gives us activation energy. Reactants acquire activation energy and get converted into. So whenever reactants acquire activation energy, they get converted into highest energy state, which is transition state. For which of the following reaction has largest value of constant? Now these two are covalent reactions, they are slow. Rusting of iron is also slow. This is ionic reaction which is very fast, so its rate constant is also great. So C is the correct option. Endothermic process among the given is, ionization energy requires removal of electron from the last shell, so it requires energy, that's why it is endothermic process. Process termed as spontaneous. Now the process of evaporation is endothermic, but it is also spontaneous. So C is the correct option. Types of system is decided by which component? So boundary decides the type of system, and there are three types of system: closed, isolated and open, and it depends upon the nature of boundary. Endothermic process among the given is, so these all processes are taken from textbook table, among which this process is given as endothermic. Path function represents. Now path function are work and heat. Now these are the modes by which system and surroundings exchange energy. So path function represents path taken to change the state. When number of moles of products and reactants are same, relationship between H and E is. So now H is equal to E plus nRT, where N is products minus reactants. So if they are same, so N equals 0 and this whole term equals 0. So in that case H is equal to E, so A is the correct option. Which is a consequence of increase in internal energy of system. So whenever internal energy of a system increases, its temperature also increases, phase change also occurs, and reaction also occurs. All these processes can happen as given by textbook, so all of them are correct. A gas is taken in a container at 1 atm pressure with area 0.5 and length changes by 30 cm. The work done is. So how can we write it? So work done is equal to pressure into area into change in length. So pressure is given in atm, we convert it into standard units 101,325 Newton per meter square. Area is 0.5 meter square and length is 30 centimeter, which in meters is 0.3 meters. So simplifying it, we get 15200 joules, which is equal to 15.2 kilojoules. So D is the correct option. Work done is 0 if heat provided to the system at constant. So now we have the equation delta E is equal to Q plus P delta V. Now when the volume is constant, so delta V is equal to 0. So this whole term which is equal to work, it also becomes 0. So at constant volume the work done is 0. So C is the correct option. Standard enthalpy changes are measured at, so standard changes in thermochemistry are measured at 25 degree, which is 298 Kelvin, and 1 atm pressure. So C is the correct option. For which of the given substances standard heat of formation is not 0? So for any element in pure state, the heat of formation is always 0. So graphite is pure state of carbon, phosphorus is pure state of phosphorus, oxygen gas is pure state of oxygen, diamond is not the pure form of carbon, so its heat of formation is not 0. 2H2 plus O2 forms 2H2O. Heat of formation of H2O from the equation is. Now here we are getting 2 moles of H2O and heat released is minus 572. Heat of formation is for 1 mole of H2O, which would be equal to half of this value. So half of this value is minus 286 kilojoule per mole. 49 gram of H2SO4, which equals 0.5 moles of H2SO4, are react with 20 grams of NaOH, which is again 0.5 moles of NaOH. So now enthalpy of neutralization would be, so 0.5 moles of H2SO4 give 1 moles of H plus, and 0.5 moles of NaOH give us 1 mole of OH minus. 0.5 moles of NaOH minus. So overall reaction would be between 0.5 OH and 0.5 H plus. So the heat released would be half of the normal enthalpy. So normal enthalpy of neutralization for 1 mole is minus 57.4. For half mole it would be divided by 2. So it equals minus 28.7. Which of the following has positive value of enthalpy? So neutralization is exothermic, combustion is exothermic, atomization requires breakage of bonds, so it is endothermic. Hess law can be used to calculate, so it is used to calculate heat of formation, lattice energy, enthalpy of indirect process, all of them. Which of the given is weak electrolyte? NaCl, HNO3 and H2SO4, all of them are strong electrolytes. Carbonic acid is a weak acid, so it is a weak electrolyte. In the equation, 2NH3 forms N2 plus 3H2. Now here NH3 is losing hydrogen, so it means that NH3 is being oxidized. The substance that loses electrons in redox reaction is, so we have two substances A and B. Now the substance which loses electrons give these electrons to the other substance, so it is oxidized itself but it reduces the other substance, so it is called reducing agent. So A is the correct option. To deposit 20 grams of calcium in electrolytic process, the amount of charge required is. So calcium ion requires 2 moles of electrons to get deposited in 1 mole. So 2 Faraday of charge deposits 1 mole yani 40 grams of calcium. So 20 grams of calcium would be deposited by 1 Faraday of charge, which is equal to 96500 coulombs. So A is the correct option. A substance is electroplated using 85 gram of silver nitrate completely, and in the process silver anode is used, and in the solution we have 85 grams of silver nitrate. The amount of silver left in the beaker is. So whenever we are using a salt of a substance in electrolytic process and we are using anode of the same substance, तो ऐसे केसेस में यहाँ से जब हमारे पास सिल्वर डिपॉजिट होगा हमारे कैथोड के ऊपर, तो जितना सिल्वर कैथोड के ऊपर डिपॉजिट होगा उतना ही हमारे एनोड से डिसॉल्व होकर सोल्यूशन में आ जाएगा. तो दिस अमाउंट स्टेज कांस्टेंट. सो ए इज द करेक्ट ऑप्शन. Change in electrode potential with change in concentration is dealt by. So electrode potential can be changed by changes in pressure, temperature, concentration, all of them. So change in electrode potential by concentration is given by equation called Nernst equation. In the galvanic cell, the metal plate with higher oxidation potential. So the metal plate with higher oxidation potential works as anode in galvanic cell, and anode of galvanic cell has a negative charge. So B is the correct option. Any electrode coupled with She gives a reading on voltmeter. So whenever we couple any electrode with that of standard hydrogen electrode, so its oxidation potential can either be greater or be lower than that of the standard hydrogen electrode. So it gives us the simple potential of electrode, which can either be oxidation or reduction. Platinum is used in SHE2. So here we use platinum in SHE because it is inert metal, it does not react. Here we give H2 gas and here we have H plus ions. So now this platinum acts as a surface provider for the reaction between these two substances. So it provides surface for electrode reaction. Calcium lies above aluminium in electrochemical series. So calcium can. So if calcium lies above aluminium, so it can reduce aluminium. Now when coupled with aluminium, it will act as anode because of greater oxidation potential. And when it acts as anode, it will oxidize itself and give electrons to aluminium. So all of them are correct. Zinc can be displaced from zinc sulfate by. So zinc can be displaced by any element that is above zinc in the electrochemical series. So among all of these, the substance that is above zinc is aluminium. NaOH can be manufactured by electrolysis of. So whenever we take concentrated NaCl, so in concentrated NaCl, hydrogen is deposited at the cathode and Cl minus is deposited at the anode. So we are left with NaOH solution. So NaOH is manufactured by concentrated aqueous NaCl. The volume of oxidation number of chlorine in HClO3 is, so HClO3, here hydrogen is +1, 1 oxygen is -2, 3 oxygens are -6, so chlorine is +5. So C is the correct option. Which is incorrect about standard electrode potential? It is the difference of potential of a cell consisting of particular electrode and SHE. It is the potential set up when electrode is in contact with 1 molar solution of its ions, The electrode potential of single electrode can be measured directly. So which of the following is incorrect? So the first two statements are correct. The third statement is incorrect because potential of single electrode can never be measured directly. We require another electrode to get the circuit complete to measure the potential of the first electrode. Thank you.